Hi, Year 11, this is Mr. Lim here again, and this is our, 7th video on hydrocarbons, and today we're going to be doing cyclic hydrocarbons. So let's get started. All right, so we've done lots of hydrocarbons, now we're going to do cyclic ones, that's what we're going to do. All right, so some hydrocarbons can form ring structures, which means that there are no terminal carbons, effectively they make a little circle, okay? They're identified by adding the prefix cyclo to the main chain name. So instead of it being propane, it'd be cyclopropane, something like that. Okay? Because there are no terminal carbons, right, the numbering of the carbons depends on the functional groups or side groups presence. Because in a straight chain, we would normally just go from left to right or right to left, right? Because there's no right or left, because it's a circle, we have to start numbering depending on those functional groups and side groups. Okay, so the functional group or the side group which has the most precedence, so generally it will be the double bond, the triple bond, then it will be the halides, and then it'll be the side groups. Whichever one has the most precedence is numbered the lowest. Effectively, we get number 1, right? So with double and triple carbons, triple bonds, having number 1 and 2 carbons in the carbon chain, right? If the functional side groups all have equal precedence, then the carbons are numbered to get the lowest possible combination of numbers. All right, so let's go have a think about what some of those could be. So here is okay, now obviously there should be hydrogens on there, but I'm not going to draw them out. So this is cyclohexane, okay, nice and easy. So if I start off with a side chain here, this is methyl cyclohexane, okay? Now, I wouldn't have to number it because it's going to automatically be on the number 1 carbon, right? So if I was to have this here, this is dimethyl cyclohexane, and I've got to say, where are the 2 carbons, right? They've got to be on number 1 and number 2 because those are the lowest possible combinations of numbers, right? And it doesn't really matter if you number it 1 or 2 that way or number 1 and 2 that way. So it doesn't really matter if we go clockwise or anti-clockwise. So let's go through so you would notice that that one there is actually different to this one here, which is another dimethyl cyclohexane, but now this is 1,3-dimethyl cyclohexane, right? So that's the numbering of these here. Okay, so let's go put in a couple of other things. Let's go put in a bromine here, let's go put in a chlorine here, and let's go put in an ethyl group here. Okay, so which one gets highest precedence? It's going to be the bromines and the chlorine, as they are halides, so they're going to have a higher precedence. So what's going to happen is that when you number them, you've got to make sure that they have the lowest possible combination of numbers. All right, let's move this ethyl group here to make this a bit of a better example. Right? Which way should I number it? One of those two is going to be one of those 2 halides is going to have to be number 1. Should number 1 be on the chlorine or number 1 be on the bromine? Okay, have a think. If you said that the number 1 should be on the bromine because you can number it better going this way, then you are correct. Okay, because if you have it number 1 on the chlorine and then you go the other way, then you're going to end up with a 136 rather than a 134, right? So you should try and number them in a way that would make the numbers have the lowest possible total, all right? So that would be 1 bromo, 3 chloro, 4 ethyl cyclohexane, right? Let's do another example. Okay. Let's do this. Oh, I should have kept count of how many carbons that is. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there. Okay. 8, that's an octane or cyclooctane. Okay. There are 2 double bonds there, and so you have to work out how to best number it. But then I'm also going to put in some chlorines over here. Right, maybe a bromine over here, maybe a side group here as well. Okay, cool. So let's do this. Okay, so first of all, we have to work out how to number it. Should I number it clockwise or anti-clockwise, and which way should I number it from? Okay, so we know that the double bonds have the highest precedence, and so therefore they should get at least the number 1. So the two options are here to number it from number 1, 2, 3, 4, or I can number it 1, 2, 3, 4. Both of them get 1 and 3 on the double bonds. So both of them are viable when you're dealing with double bonds, but now we have to look at the other ones and then work out which one should be used to get the lowest possible combination of numbers, right? So if I use the, the anti-clockwise numbering, which is the black color, I'll have something on 5, 6, 7, and 8. Whoops. Something on number 5, 6, 7, and 8. Yep, and that's a number 1 still. So I'll have something on 1, 5, 6, and 8. 1, 5, 6, and 8. If I use the yellow numbering, I'll have something on 5, 6, 7, 8. I'll have something on 4, 5, 7, and 8. All right. So which one has the lower combination? The black numbering or the anti-clockwise numbering? Okay. So that would be the one that would be picked, right, to give the numbering system. So this would be using the anti-clockwise numbering system. What's this going to be? 5 bromo. Remember, this has to be in alphabetical order. So 5 bromo, 7, 8 dichloro, 1 ethyl, 1, 3 cyclohexadiene. Okay, and that would be the that substance there. All right, so that's cyclic hydrocarbons. We'll be moving on to something else. Adios.